Guys, Cody here with Advanced Power Quality. Today I wanted to take some time and talk about self-healing teams. I had a lot of customers recently contact me, hey, I'm getting these postcards, I'm getting these emails, my utility saying that they're installing a self-healing team in my area. So I wanted to explain what this means, what a self-healing team is, and how they operate. Now this is going to be a two-part series. Like I said, I'm going to first explain what self-healing team is, how they operate, and then in part two, I'm going to speak to our residential industrial customers on some negative side effects from the self-healing team. And I also want to talk to our system planner, utility engineers out there on some items that they may not think of whenever designing a self-healing team. So let's go ahead and get into it. So these are some of the postcards or terminology that a lot of utilities are using whenever they go with a self-healing team. They call it smart, a grid, such as that. What this essentially is, they're not really creating any type of new device. They're repurposing a existing device and just using built-in features. Now, what I mean by that is right here we have our equipment and a controller box. Now, this controller box is where the gremlins live. Whenever an issue is seen, the gremlins crawl up the pole and put a band-aid on the issue. No, I'm kidding, guys. That's not what self-healing team is. So what they're doing on self-healing teams, they're replacing normally open points, which would be seen as a 600 amp switch or 900 amp switch. Some utilities go with. They're redoing these with electronic reclosers. Now, currently, Lyme and Troubleman, they have to go out in person and manually operate these 600 amp switches. What they're replacing these with are these SCADA controlled electronic reclosers. Now, the reason why they're doing this is, I have a diagram here. We have green feeder, red feeder. This is to automate and reduce outage times. So in this scenario, we only have two feeders. Right here, we have a normally open point 600 amp switch connecting the two feeders. Now, if Lyman or Troubleman in an outage scenario ever needed to divert power to another path or switch around load, they would have to manually operate these. Now it takes travel time, operations, getting everything to spec, possibly MOT such as that. With a recloser installed here in place of the 600 amp switch, what this means is the reclosers all talk to each other. Hey, I'm seeing a fault. Are you seeing a fault? No, I'm not. Yes, I am. How many times did you operate? Such as that. And they'll open and close to isolate the outage to as little or minimum amount of customers as possible. So for example, let's say green feeder here has a tree fall on the line. Normally, this would lock out the whole breaker. The entire green feed would be without power. With a self-healing team, the reclosers will talk to one another. Hey, are you seeing a fault? Yes, I am. No, I'm not. And red feed would automatically pick up green feed up to the last recloser. And it would only isolate from the breaker to this first recloser on green feed. So only these customers would be out, whereas these would still be on. Now, obviously, the communication and all this, it takes time. I have seen up to 56 seconds for just the reclosers to coordinate and switch around and go through their operations and return to a nominal state. Now, 56 seconds is an eternity for most all equipment. You talk about machines, motors, 8 to 10 cycles, is an eternity. So we're talking close to a minute. All your equipment, all your logic, everything will be down unless you have some type of ride through. Now, In addition to all this, there is a deeper dive into it where these types of equipment have to communicate to capacitor banks, regulator banks, LTCs, low tap changers at the substation. They have to also coordinate with switching capabilities. You know, what's the capacity of this line? Is that cable or overhead line conductor rated for this amount of load? Hopefully that is something that the system planning engineer is thinking of when designing all this. It's a lot more in depth. You know, for this example, we only have 2 feeders. It's very normal to have 3, 4, 5 feeders and 30 or 40 reclosers all coordinating and talking to each other on top of the capacitor banks and regulator banks and all your SCADA. If you have smart meters, it's a great idea to throw that into the mix to all communicate to one another. You know, what is the customer actually seeing? But yeah, guys, that's a just very brief overview of how they work and what they are. Like I said, it is a lot more complicated than just one open point. You're gonna have, you know, 20, 30 open points, if not more. And I just wanted to briefly touch on, this is what I mean by a capacitor bank. This is what they look like. You have your controller box here. They are all fused. And this is something that I'll get into in part 2 with potential issues. But they all are behind a fuse link with each face cell. And additionally, you do have regulator banks and such as that. Again, guys, feel free to tune in to part 2 where we'll dive into it deeper. I'll explain some of the issues, and I also wanted to talk to our planning engineers on a lot of items that they may not think of. And again, in part 2, APQ will kind of go over some mitigation techniques, and you know, at what point do you need to bring us in to do a PQ study and possibly purchase equipment that can prevent damage due to these self-healing teams operating so frequently. But again, guys, thanks for tuning in. Check us out in part 2.